a point is from a mean, the distance a point is from the mean measured in standard deviations. Okay? Or we could say another way is how many standard deviations we are from the mean. Okay? And we said we might have seen this formula. Z is equal to x minus the mean x bar divided by s. Okay? This is at least familiar, right? Maybe not right at the top of your head, but this is at least familiar. Okay, so today we are going to use this very extensively. Okay, we have a z table, and so z-scores actually correspond to our z table. Okay, a normal distribution. So the normal excuse me, my voice is all cracking and it's like I'm 15 again or something, you know. No, I taught a class earlier today, and it was a 3-hour class also. So I teach a lot. It's the only way I pay my bills. So, and they happen to all be 3 hours at a time. So, so today I'm like speaking. It's going to be for like 6 hours. So that's always rough on your voice, right? Okay. So anyway, the normal distribution is a theoretic distribution. Sorry. Theoretic. Should have bought a bottle of water. Normal distribution is a theoretic distribution. Okay. It is defined by a mean, and the symbol that we use for mean here is mu and standard deviation. And the symbol here is sigma. Okay, so this looks like a little U with a line in front. Maybe it looks like a little M, okay, but the line in front is longer than the line in the back. And then this here looks like, I don't know, that's a sigma, okay? A 6 turned over on its side or something, okay? So when we are talking about z-scores for the normal distribution, we use z is equal to x minus mu divided by sigma. Okay, same exact thing. It's the distance from the mean expressed in standard deviations. Okay, so z-score is still the distance from the mean standard deviations. And so here's the really neat thing is that if you have two normal distributions, they're going to be different, but if they're both normal distributions, we can talk about you know, what percentage has a z-score of 1 or lower. Okay, so if we think about men in the United States, the height of men in the United States follows a normal distribution. The average height of a man in the US is around 5'9½", so somewhere between 5'9" and 5'10", and the standard deviation is about 3 inches. Okay, so let's say it was the average height was 5'9½". One standard deviation above average would take us to what? So 5'9½". So we'll do an example here. Okay, so we'll say heights of males in the U.S. Okay, so here let's ask Google what is 5'9". 9.5 in centimeters, just for our international students, just because I know this is so awful. 69.5 inches in centimeters. Okay, so we'll just say 177 centimeters. Is that okay? Okay. So we'll say 69.5 inches or 177 centimeters. And so this is the mean. Mu is this. The standard deviation is 3 inches. I think that's going to be like, so 7.6 centimeters. We'll just say 7.5. Okay, so about. So these are approximations, you know. The difference between 7.5 and 7.6 centimeters is, you know, 1 millimeter, right? So we're not talking huge differences here. So something around here and here. Okay. So if we talk about a man has a z-score of +1. That means he is 1 standard deviation above the mean. What is his height in inches? Yeah, so his height is 69.5 plus 3, 72.5 inches. Okay, we'll ask Google to calculate that for us. Or actually, I can tell you right now, it's going to be approximately 184.5 centimeters. Okay. I'm only doing this. Don't worry. The Americans, don't worry about these centimeter things. Okay. I'm just doing this for our international students, so it can relate to their knowledge of the world, right? Because nobody else uses inches other than the U.S. and Burma or something terrible. Okay, I don't know. It's like 2 countries, 3 countries or something. All right, so someone has a z-score of +1. Okay. Let's talk about SAT scores. Did anyone here take the SAT? Yes. Okay, so some of you have. All right, so the SAT is a standardized test. I'm sorry? Okay, SAT is a standardized test for any one section. So let's say the verbal section. Has a mean of 500 and a standard deviation of 100. Okay. So a person, a student, with a score of 600 has a z-score of what? +1 also. Okay. So because both this man who's 72.5 inches and this student who has a z-score of 600, I'm sorry, not z-score, has a SAT score of 600, both of them have a z-score of +1. So when you compare them to the rest of the nation or whatever, and we ask what percentage of people are shorter, or what percentage of males are shorter than 72.5, the answer to that question is the exact same as the answer to what percentage of students have verbal scores less than 600, because they're both talking about z-scores of +1. Okay, so for both questions, okay, so if I ask what percent of US males are shorter than 72.5 inches, and if I ask what percent of students have SAT scores, SAT, I should say verbal score lower than 600, okay, both answers are the same. Are the same because both numbers correspond to z-scores of +1. Can you guys see that? Okay, and so if I look up z equal to 1, what is that answer? That is correct. The answer is 0.8413, okay? Because we are looking up z equal to 1.00, and so the area to the left of z equal to 1.00 is 0.8413, okay? So the answer to here, 0.8413, when we look up z equal to 1.00. How does that feel? Do you guys think you can try a problem on your own? All right, we're going to try one, okay? Because you're going to have to be able to do this. Oh, sure. Absolutely. That's my favorite thing to do for you guys. Something is wrong. Dang it. I hate when my computer doesn't do what I want it to do. Okay. Okay, is that good? All right, we're going to go to the next slide then. Okay, so let's still deal with verbal SAT. Okay, so we'll say verbal SAT has mean equal to 500 and standard deviation equal to 100. I'm going to ask a simple question. What percentage of students have verbal SAT scores lower than 670? I think that's correct. All right, I'm going to just go ahead. All right, do you guys want another minute? Do we know what to do? Can we get started? Okay. So I'll give you the hint. The first thing you want to do is find a z-score. So you're going to do z is equal to x minus mu divided by sigma. That's going to be your first step. Okay, and the answer all right, so what do we have? We have x is equal to a score of 670. The mean is 500. I'm going over the answer, you guys. And the standard deviation is 100. So all I've done is plugged in the information that I have, and I get z is equal to 1.7. So z equals 1.7. If I were to draw a picture, I'm going to go to 1.7, and I'm asking how much is shaded over here. This is what we want to do. So I go to the table and I look up z equal to 1.7. And what the table says is that the area to the left of 1.7 is what? 0.9554. Is that the answer that I'm looking for?
Yes.
Yes, this is the answer, okay? On the other hand, let me just change this question ever so slightly. And I ask, what percent of students have verbal scores higher than 670? What is your answer there? Okay, you do 1 minus 0.9554, and we would get 0.0446. Oh, and I'm sorry, so this actually, because it's asking a percentage, I should answer 95.54%. And over here, the answer, I should be answering 4.46%. How is this? Good? Is everybody written down, or can I go to the next slide? Okay, I'll wait. How about now? No?
What are the x, the n, and the delta represent? Number represent number.
The mu is the mean. The sigma is the standard deviation.
Right.
Okay? So we're just getting the distance from the mean, x minus mu, but we want it in standard deviation, so that's why we divide by this standard deviation. Yes?
So I don't understand the higher and the lower.
I'm sorry?
I don't understand like the lower than 617 higher than. How does that change the graph?
All right.
Sigma and mu are symbols that you're going to use in
So have SAT scores lower than 670? Have SAT scores higher than 670? You don't understand the difference there?
Yeah.
Okay.
Like how does that
All right, let's just change the question, okay? So, how tall is LeBron James? Does anyone know? Let's ask. How tall is LeBron James? Okay. Google says he is 6'8" or 2.03 meters. I will trust what Google says. All right. Is that tall? Is LeBron James tall compared to the average American? Yes, he is very tall. Okay? So I can ask you two related questions. What percentage of Americans are shorter than LeBron James? Or have heights lower than 6'8"? That's essentially the same question, right? If I say, what percentage of people are shorter than LeBron James, that's the same question as saying, what percentage of people have heights lower than 6'8"? And what is your answer? Like 99 point something percent, right? Like how many people are taller than LeBron James? Not very many. That's the related question, right? So we're going to say like 99% of Americans, probably more than that, are shorter than LeBron, are shorter than 6'8", have heights lower than 6'8". What percentage of Americans have heights higher than 6'8", or have heights higher than 2.03 meters? And you would say less than 1%, right? If over 99% have heights lower than that, then that means less than 1% have heights higher than that, okay? So does that clear up what's happening over here? We're essentially asking the same thing, except now it's just SAT scores rather than heights. So if 95% of people have scores lower than 670, what percentage have scores higher? 4.46%. Does that make sense?
Yep.
That's all we're doing, okay? So there is a difference between what's higher and what's lower, but it's very easy to go from one to the other because everything has to add up to 100% or everything has to add up to 1, okay? Who's the tallest player in the NBA? Let's ask. Not, yeah. Tallest player in the NBA. Oh, look, somebody else already asks that question. Tallest, this is not the answer I'm looking for. List of tallest players in the NBA. This is.
It said it right there.
It said right there? Oh. Who's this? Active NBA. All right, this is, we're getting sidetracked.
It said it before.
It said before?
Yeah, right there, bottom. Hashim.
Oh, Hashim Tabit. Oh, yeah. Shrimpy, 7'3", okay? And in some cases, all right. Well, anyway, thank you, Google, for answering this very important question. Okay. Yes?
Okay, so the same question that we had before, if you would, the first question that you said, if you would say higher instead of lower, how would you put it in the equation?
If I said higher instead of lower, I did exactly that right here. Right? So all I did, this question is exactly the same. Instead, I just said, what percentage of students have verbal SAT scores higher than 670? That's exactly what I did here.
So you have to do the first part.
You have to do the first part, exactly. So in order to get this, you have to do this part first. Okay? So if on the test, and it's very possible, maybe I don't show you this first part. I just show you this part, okay? Well, then you have to know, well, first I have to find out who's shorter or lower, and then I can get the answer for who's higher, okay? Because the table always gives you the area to the left. So you always find the area to the left first, and then you go to the other one, and you do 1 minus that. Okay, is that good? Okay, that's a fair question, or it's a good question, and I think it's fair for me to just ask this question. So let's try this out. Let's just test your newfound knowledge here. I'm sorry? All right, let's just say, I don't know. What is head circumference? Head circumference chart girl. Sure, let's go. Yeah, this is terrible. Okay. So if you are 25, the average head circumference for a girl is something like 48 centimeters. Okay? 46, 47. Yeah. Okay. So 47 and a half centimeters. Okay. So we're talking about head circumference. If you guys care about this. So what size hat do you wear? All right, so the mean head circumference for 24-year-old female, so that's like adult female. Apparently your head keeps getting bigger until then. We will say is 48 centimeters, just to keep things simple. Okay. And we will say the standard deviation, and this is just an approximation, okay, is 1 centimeter. Yeah, about.
Would it be important to write that for female or for girls, or does it make a difference?
Apparently it's different for dudes, so we'll just okay. We'll say 1.2 centimeters. Okay, so make sure you have these numbers. Mean head circumference for, oh yeah, 24-year-old, I guess girls, is 48 centimeters or 28. If you're 24-year-olds, you're a woman, right? 24-year-old females. I wonder what the highest age of majority is in any nation. So in the US it's 18. That's when we recognize you as adults. In other places it's 19 or 16. I wonder what the oldest is. I think Japan is 20. Anybody older than 20? Well, in the US we give you like half majority, right? Or like 90% majority, except like if you want alcohol you have to be 21.
And if you want to rent a car, you have to be 25.
You can rent a car under 25, but your rate's going to be different, yeah. And that's more so, that's because of insurance, not by law.
You can't go out of state if you rent a car under 21.
Okay, well, so maybe that's also true. Okay, so anyway, head circumference. So we'll say it normal distribution. Too bad there's no famous people with giant heads or little heads.
George Lopez.
Huh?
George Lopez.
George Lopez, but he's not a 24-year-old female. So, all right, let's just say some girl has a head circumference of 23.1 centimeters. Okay. I'm going to ask what percentage of, so some 24-year-old girl, okay, what percentage of 24-year-old females have bigger heads? Okay, bigger heads meaning larger head circumferences, okay? We'll be specific, okay? Have larger head circumferences. I wonder, is that okay? So try that out. Some girl has a head circumference of 23.1 centimeters. Now that sounds really, oh, not 23, I'm sorry. I screwed that up, 47.1 centimeters. I'm like, 23 point, that's a tiny head. That's a genetic problem here. Okay, so some girl has a head circumference of 47.1 centimeters. What percentage of females have head circumferences larger than that? Can we do this? Yes, we can. Okay, how are we doing? Did we get 77.34? Yes? Oh, great. Okay, so those of you who did not, or if you just want to just check how we do this, we see Z or Z, if you are British or whatever. You learned the other alphabet, the wrong one. Okay, so you get negative 0.9 on the numerator divided by 1.2. You get Z of negative 0.75. Okay. 0 goes right here. I go to negative 0.75. I shade everything to the left. And so I look up 0.75 and I get 0.2266 in the table. Okay? But here I'm asking who has a larger head circumference. So what I want, okay, this is what we want is the area over here. So I'm going to do 1 minus 0.2266 and I get 0.7734. Is that okay? Good. Can I go to the next slide? Okay, so here we go. All right, so we will still say head circumference has a mean of 48 centimeters and a standard deviation of 1.2 centimeters. Okay, but now I'm going to ask, you're going to design a helmet. And you want the large size to fit up to the 97th percentile. Okay, so what is the head circumference of someone in the 97th percentile? Okay, what does it mean to be in the 97th percentile? Do you guys know? It's not the mean. Yeah, okay, so the 97th percentile is the spot where 97% has values lower than you. Where 97% have lower values. Okay, or 3% have higher values. So 97% means 97th percentile is the spot where 97% have lower values. 30th percentile is where 30% have lower values. 63rd percentile is where 63% have lower values. Okay, does this concept make sense? Okay, it's very similar to the idea of a quartile, right? First quartile is where 1/4 have lower values. Second quartile is where 2/4 have lower values. Here it's just percentiles. So 97th percentile is where 97% have lower values. Okay, so is the 97th percentile going to be bigger or smaller than 48 centimeters?
Yeah.
Bigger, right? Because 48 centimeters, what is that percentile? So what percentile is that? The 50th percentile, right? Half are bigger, half are smaller. So the mean and the median are actually equal for the normal distribution. So the 48 centimeters is the 50th percentile. The 97th percentile then has to be bigger than 48 centimeters. Okay? So we want to know how big is the 97th percentile. Okay? So this is kind of just the reverse question, right? So now I want to know what is this location if my shaded area, how much is shaded now? Shaded to the left. So if I set my picture up correctly, how much have I shaded over here?
97%.
Yeah, I have shaded 97%. So this area is equal to 0.97. And I want to know what location gives me the area where the left is 0.97. So what do I look up in my table? I want to look up 0.97. Do I look up z equal to 0.9 and the column 07? No, that's not what I want, right? I'm going to look in the area, the number that's closest to 0.97. Okay, so I have to look through all of these numbers. Luckily, they're in order. And the number I find that's the closest to 0.97 is this one right here. I don't know if you guys can see it. Okay? There's a number, 0.9699. This is the closest value to 0.97, right? Because 0.97 is 0.9700. In the table, we find 0.9699, and that's pretty darn close to 0.97. You can go, it might be the one bigger, it might be the one smaller, but in this case, it's between 0.9699 and 0.9706. So this is the closest one. And this corresponds to a value of 1.88. Okay, so the z that corresponds to 0.9699, so z equal to 1.88 gives the area 0.9699. Is that okay? So is my answer 1.88? What is the head circumference of someone in the 97th percentile? Is my answer 1.88? No. What is my answer? This is 1.88 is the z-score of someone in the 97th percentile. Okay, so how do I go from 1.88 to a head circumference? Do you know? Okay, well, let's go to our z formula. I've got z is equal to x minus mu over sigma. So I have z equal to 1.88. That's equal to x. Do I know what x is? No, that's the head circumference that I'm looking for. What is mu? 48. What's sigma? 1.2. Okay? So do we know how to solve for x? We should. Okay, so go ahead and solve for x. And you multiply both sides by 1.2, right? You do 1.2 times 1.88, and then you add 48 to both sides. And you get x is equal, so let's punch this into our calculator, 1.2 times 1.88 plus 48, and I get 50.256. So the answer to our question here the head circumference of someone in the 97th percentile is 50.256 centimeters. Okay? I mean, that's way more precise than we need to be. We probably don't ever measure in up to the thousandth of a centimeter, but there you have it. How's this?
Can you go over the last red part?
The last red part? Right here?
Yeah.
So this is just, all I'm doing is algebra, okay? So to solve for x, the first step I would do is multiply both sides by 1.2. Okay, and so these cancel, right? And then what would the next step then be? I would add 48 to both sides. Is that okay? Okay, and that's all I've done. So I got 1.2 times 1.88, and I added 48 to both sides, so I'm left with x on this side. And then I have 48 plus 1.22 times 1.88. Okay. Is that all right? So it's just solving for an unknown in algebra. You guys should be able to do that. Okay. All right. Anybody else? Okay, so let's try an example for you to solve on your own. Okay, so we will say verbal SAT. Is that okay? Has mean 500 and standard deviation equal to 100. Okay. A school has a minimum score minimum required score equal to the 40th percentile. Okay? What is the minimum score of this school? So basically I'm asking, what is the 40th percentile? So I'll give you a couple minutes to solve for that. I guess I'll go ahead and put the answer up. I'll allow you guys to figure this out. How are we doing? Okay, let's try this out. I know some of you guys are still working, and that's okay, but we got stuff to cover. So school has a minimum required score equal to the 40th percentile. What is the minimum score? So we want to know what Z gives me such that the area over here is equal to what? 40%, right? I want over here equal to 40, and so I want to know what is this value right there? Okay. So if we go to our table, what is the Z that we get? Negative 0.25, right? It's not 3.3446, or it's not 0.6554. Okay? We are looking up the number that gives us the answer closest to 0.40. Okay? And so the answer there is 0.4013, right? Z equal to negative 0.25 gives an area to the left of equal to 0.4013. This is the closest number. Value to 0.40. Okay? So if Z is equal to negative 0.25, what score does that correspond to? So we say Z is equal to x minus mu over sigma. I have negative 0.25 equal to 500, x minus 500 divided by 100. So just doing algebra, I multiply both sides by 100. So I have 100 times negative 0.25 equal to x minus 500. And I add 500 to both sides. And so I have 100 times negative 0.25 plus 500 equal to x. So I get x equal to 475. Is this all right with you guys?
Yes.
Okay, so please study this problem as well as the other problems that we looked at today. You will definitely see questions like that on the midterm exam. I'll post a few more practice problems. You have some in your homework as well. Okay, there's another topic that we need to cover, and this is called the binomial model. Okay, I know we only have 20 minutes, but it's relatively easy, or it is very easy, because we're just covering how to use the table. We're not actually going into the binomial formula, okay? All right, so the last thing is the binomial model. Okay, so all binomial problems will have n, p, and x. Or actually, let's do have an n, an x, and p. N, x, and p. And once you determine what n, x, and p are from reading the problem, it's just a matter of looking those values up in the table. So if n is equal to 4, x is equal to 3, and p is equal to 0.2, you go to your binomial probabilities table, which starts on page A4. You first look up n equal to 4 right here. Within n equal to 4, you look up x equal to 3. And then you go to the column where p is equal to 0.2. You guys see this? And the answer to your question will be 0.026. Okay. Okay, so using the table is the easy part. You look up n equal to 4, x equal to 3, you go to the column 0.2, and you get 0.026. Yes?
For the midterm, will we have to use this chart? Will we be giving
Yes, I will be giving you both the normal table and the binomial table. Okay? Does looking up, if once you have nx and p determined, does looking it up in the table make sense? It's easy, right? So,
No, yeah.
okay, so let's try another example. If n equals 5, x equals 2, and p equals 0.3, don't shout it out, but what is our answer? Think about it, don't shout it out. See if you can look that up. Our answer is 0.309. First I go to the n, and I find n equal to 5. Okay? All of these numbers here correspond to n equal to 5. Okay? So within n equal to 5, I then go to the next row, x, or next column x, and I find x equal to 2. Okay? Now that I've got n and x, and I'm in this row, I go to the column where p equals, see, you're missing this, but p is equal to 0.3. Okay? So n is 5, x is 2, p equal to 0.3 gives me this value right here, which is 0.309. Can you guys see that? Okay? So you have this table, and it's just a matter of determining n, x, and p. So the hardest part in the binomial problem is not figuring out figuring out what the answer is using the table. It's figuring out what n, x, and p are, and also deciding if you're even doing a binomial problem in the first place. So what does a binomial problem look like? Okay, so binomial problems, let me do binomial problem examples. Okay. You will flip a coin 5 times. Each time you flip it, there is 0.5 probability that the coin lands heads. Sorry, my voice is really going right now. And we ask the question, what is the probability that the coin lands heads 3 times out of 5? This is a binomial problem here. Leave a little space there. I'm going to give you another example. Chris Paul. What is his basketball free throw shooting percentage? Sorry, I like the NBA. Okay, so free throw percent. It's pretty high. It's like 90-something%. Let's see. Chris Paul. Let's see. Free throw percentage, 90%. Okay. 90. He's a 90% free throw shooter for this last season. Okay. Career average 86%. But we'll give him. We'll say 90%. Okay. So Chris Paul is a 90% free throw shooter. Huh? Okay, so let's say each shot is independent of the other. Okay, Chris Paul, so CP3, takes 8 free throw shots, I should say, in a game. What is the probability that he makes exactly 7 of the shots? Okay. So both of these are binomial problem examples. I'll let you guys finish writing these down. They are, can you guys see the similarities in the setup of these questions? Okay? We are repeating a random thing n times. Every time we repeat that thing, there's a probability of a certain outcome. We call that outcome, whether it's a good thing or a bad thing, to be a success. Okay? And we are asking, what is the probability of getting a certain number of successes out of the trials that we have done? So in this case, the n is 5. This is how many times we are repeating it. N is 5. X is how many successes we want. So what is that? 3. And P is the probability of a success for one trial. And so here we have P equal to 0.5. So if I look this up, 5, 3, and I go to 0.5, the answer here is 0.312 using the table. Okay, so n number of trials, x number of success, not necessarily a good thing or bad thing, it's just of a particular outcome, and P is probability of success for one trial. Okay, so I want you to figure out what n, x, and p are for the Chris Paul example. Don't shout them out. Yeah, if you want to look it up in the table, you can as well. So. Hmm? Oh, the Clipper game?
Yeah. 7-2-69. Spurs are up.
Spurs are up, okay. How much time left?
Third quarter.
Oh, that's plenty of time.
Yeah.
Plenty of time. All right, what do we get for n? 8, right? So how many times we're repeating something, how many trials? He's going to take 8 free throws. What is the number of successes that we're interested in? 7. What is the probability of a success anytime he takes one shot? 0.9. So we're going to go to our table and we go to n is 8, x is 7, and we go to the column 0.9, which I think is this one right here. And so the answer is 0.383. Is this okay with you guys?
Yeah.
All right, so let me just, so again, the hardest part is identifying, is this problem binomial? Because on the test, I'm not going to say, hey guys, this is a binomial problem, so do it this way. I'm just going to write the question out, and you got to figure out the answer yourself. Okay? So yes.
Are you going to put the questions in like chapter 1, 2, 3?
I'm not going to put them in order from chapter 1 through chapter 6. That makes it a little too easy, okay? So thank you for the question, but it's not going to go that way, all right?
Can you show us an example of something that would look like a binomial but isn't? Like if you're gonna have some trick.
I don't, that's a hard question, right? Like, can you show me a picture of something that looks like a duck but is not a duck?
Well, since you said we have to identify.
Yeah,
what is
yeah,
a binomial, I was like.
Well, I mean, so study what these questions look like, and study what the other questions look like.
Are there any keywords?
Yeah, so let's talk about, is this a binomial problem? Okay. Okay? For it to be binomial, there's certain things have to hold true, okay? For a problem to be binomial, okay? I guess probably it gets confused with just regular old probability problems. For a problem to be binomial, okay, you must repeat a random thing n times, okay? So just a certain number of times, it doesn't matter. But you have to repeat something more than once. Same thing, okay? Each trial, or each repetition, must have the same probability of success. Okay? And then you are interested in the final count of successes only. I will note you are not interested in the order. Okay, so let's try something out here. A coin has probability equal to 0.5 of landing heads. You flip the coin three times. What is the probability it lands heads on the first flip? But does not on the other flips? What do we do here? We are not interested in order. This is not a binomial problem, okay? This is not binomial. Why? Because this question says we want to know if we got heads on the first flip. So what kind of problem is this? This is a regular probability problem, like you saw in the quiz. So the first flip has to go heads, and then you have to go tails, and then you have to go tails. So the probability of getting heads is 0.5, probability of tails is 0.5, probability of tails is 0.5, and we get the answer of 0.125. Contrast this problem. So I'm going to just go ahead and copy this just onto the next slide, so don't freak out here. Okay, so that's up there now. Contrast this to this problem, okay, and I'm going to just say it starts off the same way. A coin has probability 0.5 landing heads, and then I ask the question, what is the probability that the coin lands on heads exactly one time? Out of the three flips. Can you guys see the difference between this question and this question? This one is binomial. Okay? And what is my n, what is my x, and what is my p? N is 3, x is 1, and p is 0.5. So let's look this up. And what do we get? 0.375. So the answer is equal to 0.375. I want to just point something out here, okay? There's a relationship between these two. and you don't have to worry about this. But when I say exactly one time out of 3 flips, there are 3 ways this could happen. I could get heads, tails, tails. I could get tails, heads, tails. And I could also get tails, tails, heads. If I do the math for each of these, this one is 0.125. We did that right there. The probability, I should write probability of all of these things. The probability of each of these things is 0.125. And so if I add up all 3 of these, then I get 0.375. And that's what we're getting here. Okay? Now you don't have to worry about figuring out all the different orders. That's the beauty of the binomial table, is that it figures out all of the orders for you, does all the math for you. You just have to say, oh, this is a binomial problem. I'm going to look this up in the table, and it gives you 0.375. But we can kind of see how we might get 375 ourselves if we listed out all the ways we can get exactly heads one time out of 3 flips. Okay? So make sure you can tell the difference between these two, because you might, well, you probably will see both types of problems, and I'm not going to say this one's binomial and this one isn't. Okay? Sorry to be that guy, but I do have to test this. Okay? So I'm going to put some practice problems up by Thursday, and we'll see you guys next week. Good luck as you guys study.